Imagine being aboard a research vessel sailing toward a hidden paradise of crystal clear waters. Our destination? One of Earth's most captivating geological wonders, a blue hole. These underwater sinkholes contain secrets that have fascinated scientists and adventurers for ages. But blue holes are also time capsules, preserving evidence of historical weather events and ancient civilizations. Geologists, archaeologists, meteorologists have all uncovered remarkable clues buried within the walls of these submerged marvels. I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much, much more. Our goal is to help you better understand the weather and to love it as much as we do. Today's episode is the first in a two-part series about blue holes. Now, if you've never seen a blue hole in person, they're both beautiful and terrifying. Sometimes they're out in the ocean, sometimes they're right along the shoreline. They're so deep, you often can't see the bottom, which makes it unnerving to dive into one.
You're in this big dark hole with a bunch of sharks swimming around. It is a pretty scary experience.
Today, I'm talking to Dr. Jeff Donnelly from Woods Hole Oceanographic Institution. He led a team of researchers to the Bahamas to study ancient hurricanes by taking sediment cores from blue holes. To understand how hurricanes are changing and how our climate is changing, it's important to have a long record. But we don't really have that. In fact, we don't have reliable historical weather information prior to the 1850s. We didn't even start naming hurricanes until the 1950s. So blue holes are broadening that historical record and giving us a better idea of what ancient hurricanes may have looked like and how often they occurred. Jeff is going to share what has been learned about ancient hurricanes and about an unexpected discovery.
The edge of the Abaco Island in the Bahamas, we took a core in there. I got a call from the undergraduates who were in the lab splitting it one day, and you better come down here and have a look at this.
Now, what Jeff and his team found was fascinating, and it drastically changed what historians previously thought about indigenous Bahamians. So sit back, relax, and hold on as we take a deep dive down into the time portal of a blue hole to learn about ancient hurricanes. All right, Jeff, let's talk about blue holes. Not everybody knows what a blue hole is. So can you start by telling me exactly what a blue hole is?
Sure, yeah. Blue hole is a cave that has been dissolved into the limestone. The roof collapses and then sea level overtakes it. So it's effectively a hole in the bottom of the ocean. So it's a submerged cave that the roof has collapsed on, basically.
They're not all in the ocean, though, right? Are some inland?
Yeah, I mean, they usually call those sinkholes. The blue holes are usually reserved for the either coastal or ocean holes.
How deep can a blue hole get? How big are we talking here?
Well, in terms of depth, they can be hundreds and hundreds of feet deep. In terms of diameter, they can just be tens of feet to even hundreds of feet wide.
And they are everywhere, or do they tend to occur in certain parts of the world?
Yeah, they tend to occur in the tropics and the subtropics, where you have these limestone deposits that can get dissolved and create these caves. Restricted to a fairly narrow band in the tropics and subtropics.
All right, so an area where hurricanes happen to occur as well, correct?
What? Indeed,
All
very
right.
convenient. Yes.
Convenient. Okay, so talk about blue holes and hurricanes and the connection here. How can you look in a blue hole and see a historical record of ancient hurricanes?
So the blue hole, this is a trap for sediment. So as the ocean sea level rise overtakes it, sediment just starts piling in. And normally it's pretty fine-grained sediment that's just driven by the normal tidal currents and things like that. When a hurricane comes, it mobilizes lots of very coarse sediment and dumps that into the hole. And so it shows up as a very anomalous deposit in the hole. And so we're able to take very long sediment cores in these blue holes and reconstruct the history of these hurricane event beds.
Interesting. So it's almost like what's being done in the Arctic when they're looking at cores there.
Right. Yeah. It's similar to ice cores or even tree rings, right, where you just have this long, continuous record that in this case is interrupted by these hurricane events.
So how do you get down into the blue hole to extract? Is there some sort of fancy machinery that you're sending down there, or are you diving down? And
Yeah. A little bit of everything. If it's shallow enough, we can actually send divers down to get information on the water column, as well as what the sediment is like at the very bottom. Oftentimes, these holes are so deep that it requires some very technical diving, which is fairly dangerous. And so we try to avoid it, actually, if we all can. So we have a variety of instruments that we can either use to remotely sense what's going on at the bottom of the hole, things like sonars and things like that. And also, we can send devices down to measure water column properties. To get the cores, we typically use a big vibrating can. It's called a vibracore, and it's basically like attaching a big long straw to a big vibrating beer keg, and you just vibrate the straw into the bottom. It's sort of like putting a straw in a milkshake and putting your thumb over the top and pulling it out, and the straw's full of milkshake. But in this case, it's full of mud from the bottom of the blue hole.
And historical hurricane information. So I'm curious, why not the ocean floor? Why blue holes? Can you not just dig into the ocean floor at any point and find this information?
Yeah, and sometimes you can, but what happens is that subsequent storms will come and completely rework the record. And so it gets really complicated. You might have a really nice hurricane deposit, and then 10, 15, 100 years later, you get another really big hurricane deposit. It might completely erode the earlier one. And so what the blue hole does, it's so deep that the wave, it's well below the wave base. And so that what gets deposited in the hole stays in the hole, and it doesn't get reworked by subsequent events. And so in that way, it provides a really high fidelity record of what's been going on. And, and over millennia, the records can go back many centuries and even millennia.
All right. So how long has this research been going on? Because you're part of a team at Woods Hole and you've been doing this research. Can you tell me how it came about when you started doing the research and what you've learned?
Sure. Yeah. Well, this work sort of reconstructing hurricanes started about 25 or 30 years ago. And it was really the reinsurance industry approached us and were interested in trying to get much better statistics on these really intense but fairly rare events. And it happened right after Hurricane Andrew, where they really had a lot of losses in South Florida. And so that sort of spawned this type of research. It took us more than a decade to figure out, one, that blue holes was a really good place to look for this, and two, to figure out the technological pieces to be able to sample down there. And we were really one of the first groups to be able to sort of sort that out. And so we're using cores that were designed for the deep ocean to be operated off of big ships, but oftentimes it's only a few feet deep around the blue hole, so you can't get a really big ship in there. So we had to do quite a bit of MacGyvering to figure out how to sort of make our instruments smaller and make our platform smaller so that we could actually get into these systems to do it. And so that the actual work in the blue hole has only been going on for about a decade.
Okay, so you've got a lot of information then at this point, if it's been going on for a decade. Can you give me a little background on the historical data that we have on hurricanes now and just how minimal it is, and then what you're looking at time-wise and how far back that goes?
Sure. Yeah. So in the Atlantic, the sort of official database that's maintained by the National Oceanographic and Atmospheric Administration only goes back to 1851. So, it gives you 170, 180 years worth of hurricane data, which is pretty good. But it's for these rare events, for any one location, you may have only been hit by one or two events in that time frame. And that time also spans the interval in which people are having a pretty big impact on climate. And so it may not be very representative of sort of the longer term history. And so what this approach allows us to do is to go deeper in time, sort of explore other climate regimes before people had a big influence on climate, and try to tease out what the really important factors are in driving variability in hurricane frequency. And so these records span, as I said earlier, several centuries or even millennia. I think our longest records are about 2,000, 2,500 years from the blue holes, which is pretty exciting. One of the other things that's really nice about the blue holes is that they tend to accumulate sediments really rapidly, which is sort of a double-edged sword. On one end, that gives you very high resolution. And so, for example, a lot of the holes are accumulating at about a half an inch or so of sediment per year. And so It's why graduate students sort of go through these cores. Every sample that they're taking actually represents about a year's worth of deposition. The downside of that is that we collect, our cores that are 50, 60 feet long, and they only represent, 1,500 years worth of time. And so you don't get as much time recovered as you would in other systems. But the resolution of the record is really unparalleled.
So you're kind of a historian. Can you give me any information as to what hurricanes 2,000 years ago may have been like? Are we talking, you can narrow down categories? Can you talk about tracks? What are you learning about them?
Right. It's pretty hard to come up with intensity. We have a trouble measuring intensity now. We had to adjust Hurricane Andrew from a Category 4 to a Category 5 because we have the algorithms right from the aircraft aloft to the surface. So even today, measuring the intensity of a hurricane is not trivial. And it's pretty hard to do in a really quantitative way from the sediments, because really those sediments are recording the energy at that one particular location, right? It's not sensing the entire storm. It's basically telling you that where that blue hole was, it had really intense waves and currents that were able to mobilize this coarse sediment. So we're not able to assign categories, but what we can say is, beyond a certain energy threshold, which usually, relates to something like a Category 3 or 4 hurricane, we were able to mobilize sediments and dump them into this blue hole. And so it's sort of telling us that, there were really intense storms in that sort of Category 3, 4, 5 range, as I said, going back 2,000 years or more. And what's interesting is that there's really quite a bit of pattern in how these things are happening in time. So that the probability isn't stationary through time. That there are some intervals that are much more active than others. And so we're trying to sort of figure out exactly what are driving those trends. It's hard because the age control that we have in the cores is radiocarbon derived. So now imagine a mangrove leaf sort of floats down into the bottom of the hole, and that's preserved in the sediment. One of my students will pull that mangrove leaf out, and we'll use radiocarbon to date it to figure out what time interval that piece of the core represents. Unfortunately, there's an error on that. And, it's probably plus or minus 10, 15, 20 years even. And so we're not able to sort of really precisely date the storm. We can only do it within a couple of decades. So it makes it hard to track storms from site to site because you're not sure you're dealing with the same storm given the uncertainty of the age model. That said, provide with these is just a really extraordinary long-term perspective on the frequencies of these events. And we can, compare sites, compare regions. And one of the really interesting things is there tends to be really big shifts when, for example, the Gulf of Mexico is really active. It turns out that the Northeast is very inactive. And then, the Bahamas will get very active and the Gulf of Mexico goes quiet. And so there are these sort of spatial patterns in the activity shifting around that are likely driven by large scale changes in climate. And we're sort of trying to figure out exactly what was going on then. And hopefully that provides us, some perspective for what we might experience in the future, given what we know in terms of how the climate's changing now.
Yeah, I was going to ask, purpose-wise, what the goal is here for the future.
Yeah, a lot of the modeling efforts going on now, sort of exploring the role of the warming oceans and in terms of the tropical cyclone activity suggests that we are going to be experiencing many more frequent, intense tropical cyclones because the oceans are providing the fuel for these storms. And so most of the modeling efforts that are projecting into the future are suggesting much more active hurricane regimes. And so one of the sort of things that we're trying to do is sort of explore that. Basically, the Earth has already run this experiment for us. Over the last couple of millennia, the sea surface temperatures were warmer, they were colder, patterns and the ocean circulation has changed. So we can go back to these earlier times and say, okay, the assumptions that we're making in these models about the future, do they hold when we go back 1,000 years ago? That sort of thing.
Interesting. Are you planning to expand research to other areas? Because you've mainly been focused on the Caribbean, correct?
Right. Yeah, we've done most of the work in the Caribbean. There's been one paper published from Joliet Atoll of the Marshall Islands out in the tropical Pacific. And we have a new project funded that will be taking us on a couple of cruises out in the Western North Pacific over the next couple of years. So this will expand the work from the Marshall Islands all the way to the Philippines.
Have you gone on these missions yourself?
Yeah. So in 2016, we went to a blue hole on Sal Bank, which is a bank that's between Florida, Cuba, and the Bahamas. And it's about 100 meters deep. And the bank top, though, is about 10 meters deep, or about 30 feet or so. So we're actually able to get a fairly big ship in there. And the ship was equipped with submarines. And so I actually got to go down to the bottom of the blue hole in a submarine, which was very cool.
Oh, well, this is really fascinating information. Anything else you want to share about blue holes and hurricane history and what you've learned? Any fun surprises?
Well, in one hole, this was actually a sinkhole that was right at the edge of the Abaco Island in the Bahamas. We took a core in there, and I got a call from the undergraduates who were in the lab splitting it one day, and you better come down here and have a look at this. And so I went down, and in the middle of this core, the core is about 3 inches in diameter. In the middle of this core was what we determined to be the top of a human tibia. So a human bone was recovered in this sinkhole on Abaco in the Bahamas, and we radiocarbon dated it, and as well as sort of the leaves that were on one side or the other. And it's pre-Columbian. It dates to about 1300 AD. But that's definitely the strangest thing we've ever come up with in the core.
Wow. Did you learn anything more about it? Did they send it up?
Yeah, I mean, well, we looked at, sort of the isotopes of it and looked at, a variety of things, but it's basically, it's the second oldest human remains ever recovered from the Bahamas. And we just happened to catch it in a 3-inch diameter tube. We took other subsequent cores around it thinking there might be other remains there, but didn't recover anything else. So it was just luck that we managed to collect that one specimen.
After my conversation with Jeff, I couldn't stop thinking about this human bone they found. I wanted to learn more about it. So in part 2 of this series, I'll be talking to a paleoclimatologist involved in the research of this bone. We will find out how they dated it, what was learned about the Lucayans in the Bahamas before the arrival of Christopher Columbus. Tune in next Tuesday. You're not going to want to miss this. Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes published every Tuesday. If you have a weather nerd in your life or someone that may just want to learn more about blue holes and hurricanes, please share this episode with them. We'd also love you to rate and review us on Apple Podcasts and Spotify. Let us know what you think of the show and give me some ideas for future episodes. This podcast is produced, hosted, and edited by me. Special thanks to Ryan Berlin for his contribution. I'm meteorologist Emily Gracie. Make it a great day.